Welcome back, pre-calculus. Well, today we get to start a new section on conics, and we're going to look at ellipses today. And the essential question we're trying to deal with today is how do you solve problems involving ellipses? So again, to do this one, we've got to go back and ask how do we tell from a conic equation or an equation of a conic if it is an ellipse. And if we go back to this portion of what we talked about in the last section, here is the equation of your conic. And we look at the coefficient of x squared and we look at the coefficient of y squared, and those two numbers, including their signs, will tell you a lot about the conic. And what we're going to look at today is ellipses, and you're going to see that in here, if the A and the C, if they have the same sign. In other words, if they both have positive, it's an ellipse. If both of them have a negative, it's an ellipse. It does not matter if A and C are different numbers. They just have to have the same sign. All right? So that's what we're going to look at today. Now, starting off, we have a definition. Again, I'm really not going to go into a lot of details on that. It's seen on page 744. It just says that the set of all points, x, y, that means the set of all points on the ellipse, is the sum of whose distances from two distinct fixed points, what we call the foci, is constant. Again, I'm not going to really go into that. It's really not that important. But what I want to do is do it the way I did in the second part of parabolas. It's a little bit easier to do, but the first thing I want to do is, here is a picture of an ellipse. And I thought I'd show this to you guys just to give you guys an idea that we're going to run across two different types of ellipses. Now this is an example of a horizontal ellipse. And I'm going to show some other formulas here in a second. And the key to this one is getting it into this form right here. I'll show you how to do that when the time comes. And another factor here, which is going to be very important, is I'll show it in a little bit. Okay. The big thing we're going to focus on here, this is an ellipse. This is the center, which once again is going to be the HK, just like we did in parabolas, but that was the vertex. Okay. Other factors that we're going to have to deal with is those two fixed points they talk about. Those are called the foci. There's two of them, so it has two focuses, so that makes it a plural foci. And we can find them based upon C units from the center. And down here is the formula that you'll be using to find out what C is. All right, you with me? Now, something else that we need to know. The line that goes through the foci and the center, this is called the major axis. Now your major axis is going to either be horizontal or vertical. Hey, Hunter, over there at the printer. On the other side, Nana's computer. So this right here is your major axis, and it's horizontal. Okay. And that's going to happen when your a squared is going to be underneath the x squared. Now, a squared will always be greater than b squared. So this value right here, if this value is bigger than this value and it's underneath the x term, the major axis is going to be horizontal. Now, if it's switched, like this is a greater value than this term, that means it's under here. That means your major axis will be vertical. All right. I'm going to do two examples dealing with that, okay? Are you with me? Now, this guy right off here, this is your minor axis. There's other things we need to talk about is A units from the center gives you the endpoints of the major axis. So this is your center. This is A, which you get from down here. This is the endpoint of one side of the ellipse, and then the other side is the other one. Okay. Now, from one endpoint to the other endpoint along the major axis, that is going to be your length of 2A. I think you'll see it when we get into it. Okay. And then here's B. And then another new thing that we're going to run across here before I show the formula is what is called eccentricity. And this is the formula we use for eccentricity. Once we know what C is, once we know what A is, that value right there will tell you a lot about eccentricity. Now, eccentricity is how much this is real narrow or how wide. Again, we can focus on that. Again, as it gets closer and closer to zero, it becomes more circular. So in other words, if the eccentricity gets closer to zero, in other words, we get a small number, we get it almost looks like a circle. And the number gets close to 1, it gets a little bit narrower. Okay. Now, I have another sheet of paper here, which you can use when we're dealing with it. If you look here, this is information about an ellipse. Something to remember here, A squared is always greater than B squared. This column right here deals with the major axis is horizontal. That's this problem right here. And everything's based off of the center. We'll talk about that when we do some examples. Now, if here your vertical major axis is when, once again, if your greater term is underneath the y expression, that's going to give you a vertical axis. That's going to be this way. All right, so what I want to do is take that information and we're going to go and find certain information for ellipses. All right, you're more than welcome to write that down. I don't know if they have that in the book. All right, so let's do some examples. All right, let's get myself set up. Here is what I want to do. We're going to do 2 examples. What we want to do is we want to find the center, the vertices, the foci, and the eccentricity of the conic. I'm really not, you're more than welcome to graph these, but I'm really not interested in that because it's sometimes if you don't have that feature on your graphing calculator, graphing it is not going to be worthwhile. Okay, so here's our first problem. We have the equation 5x squared plus 4y squared minus 20x minus 2y plus 4 equals 0. Well, right now we can see that A is 5 and C is 4. They have the same sign, so that tells me that this is an ellipse. Okay, at the same time, we'll keep going on here, okay? Let's keep going on. So what we want to do is we want to get it into this form. So let's do it. First thing we want to do is take our constant to the other side. That's the plus 4. Subtract a 4 from both sides. Then we're going to group together at the same time I group together my terms with x and my terms with y. And what we got to do is we're going to do completing the square. So first thing we do is we group the first 2 together, factor out the leading coefficient, and then we have a box. Combine together the y's, do the GCF of the y, so we factor out the 4. This is where I get y minus 1/2 y, plus circle, and then since we did some operations on the left side, we have to do the same thing on the right side. Now again, you guys probably remember doing this last year when we did it in Algebra 2. So it should not be hard, okay? So what goes in these boxes and what goes in a circle? Well, you take the coefficient of x, which is 4, take half of it and square it. So half of 4 is 2, 2 squared is 4. Take half of 1/2 is 1/4, and square it, we get 1/16. So the box has 4 and the circle has 1/16. Then you're going to notice that these trinomials are perfect squares. I left a y squared out. I just caught that. So again, we can factor this x squared minus 4x plus 4 becomes x minus 2 squared. Again, what are the factors of positive 4 whose sum is negative 4? And it's negative 2 and negative 2. Same thing here. Factor form of this is y minus 1/4 squared, and add these in the right, and we get 65 over 4. All right, the next thing we do is we divide both sides by 65 over 4, because if you notice back to the form, they both have to equal 1. So to get this to equal 1, I have to divide it by its value. Then the next thing we do is we go ahead and simplify it. So 5 divided by 65/4 is 20 over 65. And 4 divided by 65/4 is 16 over 65. Now you probably noticed I just leave it as a fraction. You can do that. Don't put it in a decimal. It's going to really mess you up, okay? So the next part is we're able now to identify here that 20 over 65 is greater than 16 over 65. So that means a squared is 20 over 65. And b squared is 16 over 65. So just by looking at this, that tells us that our major axis is horizontal. All right. Then the next thing I did is I just found out what the value of a is, because we're going to need it here in a moment, and the value of b. So the directions say we want to find the center, the vertices and the foci, because we now got our problem into the way we like it. So this is the form that we're looking for. And all our information is right there where we can find our center, vertices, foci, and eccentricity. All right, so I wrote it down already. Major axis is horizontal. The center is 2 and 1/4. X minus h, h is 2, y minus k, k is 1/4. The vertices, okay, which in this case, what I mean by that, these are the endpoints of, that's the endpoints of along your major axis of your parabola, are a units from the center. So again, we know a is 0.55 plus or minus 0.55. So we already know that this the center is 1/4. That means our vertices and our foci will have the same y component of 1/4. And all we do now is take 2 and add 0.55 to it, and 2 subtract 0.45, and these will give you the endpoints of your vertices, okay? Foci is c units from the center, so we have to go up here to Otis. Using the formula, we know that a squared equals b squared plus c squared. That means c squared has got to be a squared minus b squared, and taking the square root of both sides, we know that c is, I rounded it up to plus or minus 0.25. So again, take your h, add 0.25, and subtract 0.25. And that's where I got these values here. And we have an eccentricity of 4/5. All right, now, once again, the whole purpose is getting our problem into this form. If we can get into this form, We know what H is, we know what K is, we know what the value of A is, and we know what the value of B is, and we can find all our information after that. All right, one more. This one has a major axis that's horizontal. I like to do one that where the major axis is vertical. All right, we see that A is 25 and C is 9. And we're going to go and take this whole thing and put it in this form. So all I'm going to do now is I'll just show you all the information. Completing the square. Take your x terms, get them together. Get your y terms, get them together. And take the constant on the other side. Complete the square. First, factor out 25 from the x squared and factor out a 9 from the y squared. And then you just got to keep going on, okay? And I'm not showing everything here. Again, if you look here, when we get to this form, that right there is the form of a parabola. Again, we know 25 is greater than 9, so this has got to be a squared. And since it's underneath the y term, that tells us the major axis is vertical. So all you got to do from there is just take that information and plug it in. Also, on the side, you can figure out what C units are. And again, I think you guys will have no problem. Once again, refer to this diagram right here. And you have also these formulas right here to help you out. Okay, let's be a little bit more neater, Mr. Wakanish. All right. Again, if you follow the diagram, you'll be able to figure out what the endpoints are or your vertices. And then you should have no problem doing these problems. All right, guys. That's section 10-3, finding ellipses. I don't think you'll have any problem. But if you do, you know how to get in contact with me. Catch you later.